FU. Send help. Send help. Send help.
Hi friends, today we'll be talking about one of my failed Unity projects, the Gaze keyboard. We often see developers online talk about their many successes, but if we really want to be honest about the development process, we actually fail a lot. So this is one of my failures. Here's the backstory. My dad approached me about helping a friend who was hospitalized and could no longer speak or move their body. She could, however, still move her eyes. Communication was very difficult. Someone had to hold up a chart of letters, then point at each letter one by one to spell out words. Imagine having to speak one letter at a time. In terms of building apps, I have some experience with eye tracking for gaming and therapy. So this got me thinking. I wanted to build a communication device using an eye tracker to type. Obviously, the first thing you do is to see what products are out there. So here's what I found. The biggest player in eye tracking is Tobii. They have eye trackers for communication, research, and gaming. And their Dynavox company focuses on communication devices. They have 3 products that fit the bill. There's the TD Pilot, basically an iPad with an eye tracker that costs up to $10,000. Then there's the TD I series, a custom computer with built-in eye tracker for around $15,000. So truthfully, all these devices are not cheap, and I'm pretty sure I could build the software myself. Which leads me to my third option, the Tobii 5, the eye tracker designed for gaming. The cost, around $300. It integrates with the Unity game engine seamlessly, and being the game developer I am, I can code it all myself at no cost. Here's what I built. I put together a virtual QWERTY keyboard, used the eye tracker as a cursor. Selections were made by gazing at the letters for a custom amount of time. I set it around 1 second. From this quick demo, you can see it works okay, but the tracking can be inconsistent. I can promise you I'm looking directly at the button, but it tracks the gaze slightly off center sometimes. The reason for this could be because I shifted slightly from my calibration position, so all the tracking is slightly off. And this is the limitation of monitor-mounted eye trackers. If you happen to shift around or deviate too far from your original calibration position, the accuracy tends to get worse. And if the target's too small, then you have to compensate with your eyes to make sure that the cursor is in the right position. Especially with a QWERTY keyboard, you have lots of letters to display, resulting in smaller buttons. So one possible solution is to make the buttons bigger so that there's a smaller margin of error. But with that, we'll have to reduce the number of buttons. Then the question is, how do we reduce the number of buttons? Could we use a T9 keyboard like those old school flip phones? Then we'd have 9 buttons to represent all the letters of the alphabet. Or maybe do some sort of predictive swiping like on modern phones. That way, we don't have to worry about accuracy as much, and it would predict the words that we're trying to type. Or maybe we can just eliminate the issues with monitor-mounted eye trackers in general, and switch to an eye tracking headset, like the MetaQuest Pro or Apple Vision Pro. As a side note, Stephen Hawking used to communicate with a communication device, and he could not move his body. Doing some research, I found that he actually has to twitch his cheek in order to select buttons and keys, and that's how he communicated. Maybe we can try this in another video. Let me know what you guys think in the comments below. To wrap this all up, maybe it's dramatic to say that I failed. This app just needs some improvement. The truth is my dad's friend no longer needed this app and this project fell off. But maybe this project could be useful to you or someone you know. For more failed or rather unfinished Unity projects like this one, like and subscribe. And I'll catch you guys in the next one.